All right, guys, this is lesson for Thursday, and we are going to be covering two sections in one shot here. We're going to do 3.6 and 3.7, and you are going to have a worksheet on this material. Some of this stuff you have seen before. We're going to probably add only one little item that you haven't used before, but everything that you see here should not be unfamiliar as we go about graphing our linear inequalities, okay? So I hope the quiz on Wednesday went well. Again, obviously I'm not here. I will be back on Monday. I will try to get those into the gradebook as fast as I can when I get back on Monday. Tomorrow is going to be WKCE test prep day. Okay, I will have more directions through the sub to give to you about that on Friday, but those WKCE tests are going to be next week, Tuesday, Wednesday, and Thursday. All right, so be prepared for that. Right now, let's get into our 3.6 and 3.7 solving and graphing inequalities. Our goal is to be able to graph inequalities from given statements, okay, and to put the solutions on number lines and go from the solutions to give me an inequality, okay? So graph inequalities from given statements and from the solutions of solving inequalities, okay? So you're going to look at a simple inequality, graph it, then you're going to have to solve an inequality and graph it. All right, a couple things you need to remember from last year. Inequalities can either be true, false, or open, okay? This is the same as equations, okay? So again, if I write an equation like 7 equals 8, okay? That could be either true, false, or open. Obviously, this is false, okay? If I write an equation like 7 equals 7, well, that could be true. Obviously, that's true. If I write an equation like 7x equals 49, well, that's only true if x is a certain number, which obviously would be 7, but inequalities work the same way. They could either be true, false, or open. So let's take a look at some more stuff. So for example, I have 5 is, and these are separated like this here. I have 5 is less than 5. Is that true, false, or open? Well, is 5 less than itself? No. So this is false. I have 5 is greater than 2. Is that true, false, or open? 5 is greater than 2, so that's true. M is less than 5. Well, that depends on what M is. So this would be an open statement. Okay, and we would have, by the way, how many solutions are there for M? M is equal to what? And that's going to be the part that we're going to get to graph. Is it just one answer? Okay, no, it's going to be multiple answers, right? So let's go on here. M is less than 5 is open. That means there are not possibly, there are many solutions to the inequality, okay? Many solutions to the inequality. So when we have open statements, that's going to be the time when we are going to graph all of the solutions, all right? You probably are thinking in your head right now, M is less than 5 is something that you've graphed before, and we're going to get into how to do that in the next slide here, okay? So let's get into graphing. A couple things we need to know. When we graph the solutions to an inequality, we put them on a number line, all right? Now, the number line that I have to graph that I'm going to show you is going to be very large, all right? I'm going to show you and draw for you in a couple of examples. The number lines that I want you to draw, they don't have to be very large, guys, all right? So watch for that when we get to those examples. All right, things to remember, okay? I use what kind of circle when graphing less than or greater than? Okay, the answer to that is I use an open circle, or you can put literally an open circle, all right? I use an open circle when I'm graphing less than or greater than because that tells me that the number I'm talking about, if I'm talking about M is less than 5, that tells me that 5 is not a solution, okay? That means that 5 is not a solution. That's why I use the open circle, okay? Numbers like 4.9 or 4.99 or 4.999, okay? Those are all solutions, but all the way up to 5 is not a solution, so we indicate that with an open circle. On the same token, when I'm graphing less than or equal to or greater than or equal to, I use a filled in circle, or I write a closed circle. Okay, I'm going to make my marker a little bit thinner here. So, moving on. Those are the things that we graph when we use those, okay? This means, if I use a closed circle, it means that if I have m is less than or equal to 5, that means that 5 is less than or equal to 5. That works out, right? Because 5, that's part of the equals part. 5 is equal to 5. So that works here, and we indicate that with our closed circle. All right, a couple of examples. Okay. Now, here's where you guys need to pay attention to what I want you to write for your graph. So watch this. You're probably going to like it because it's going to save you time. All right, I want to graph x is less than negative 2. Okay, what values of x make the statement true? Well, it's going to be anything smaller than negative 2. Okay, now the first thing we need to ask ourselves is what kind of circle do I have? What does this symbol say that I'm going to use? Well, if we go back up here, that means I'm going to use my open circle. Okay, so I'm going to put an open circle on the number we're talking about, which is number 2, negative 2. Open circle here. And here's how I want you to make your graphs, guys. From that 2, which way is our graph going to go? Well, we're graphing things that are less than 2, and that's less than negative 2. So my line is going to go to the left. Okay. There are lots of tricks for this. One thing is, if the variable comes first, like it does here, you can go with which way the arrow points. The arrow points to the left. My graph goes to the left. Okay. Now, if you're given this without a number line, so let's say that this number line isn't here. All right. This is what I want you to do. Here's your number line that you're drawing. The number that you're talking about goes right in the middle, negative 2, and draw 2 numbers on either side, negative 1, negative 3. That's all you need. You don't need this whole thing. Okay. You don't need that. All you need is this, and do the same thing. Open circle, arrow to the left. Okay? All right, moving on. A couple more examples. I want to graph b is greater than or equal to 4. All right, locate the number that I'm talking about. 4 is right here. All right, what kind of circle goes on 4? Well, according to this, that's a closed circle. And what am I graphing? Well, it's a greater than or equal to sign, so I'm graphing things that are greater than it, so I'm drawing my arrow to the right. Okay, again, if you're drawing this out yourself, all you need is really 3, 4, 5 on your number line, closed circle, arrow to the right. Okay, make that a little bit more closed. Next one, give me a little more space, what's on top? Graph the number negative 1 is greater than y, okay? Now, pay attention to this one. Locate the number you're talking about, negative 1, okay? What symbol am I going to use? Well, this tells me that it's going to be an open circle, and I'll get rid of the line I just drew here. I got an open circle. Which way does my arrow go? Can we use the same test that we were using before? Meaning, I have a greater than symbol. Does my arrow now go to the left? Well, no. Okay. That doesn't work because the variable doesn't come first here. Okay. If you read it from the variable side to the left, I'm saying y is less than negative 1. So I need to graph things that are less than negative 1. So my arrow actually needs to go to the left. So be careful of that when you're graphing. Okay. Make sure you're answering the question you're being asked. All right. Moving on. All right, solving inequalities then. Now we've talked about graphing them. Now we need to solve inequalities. Solving inequalities. Everything for solving inequalities is exactly the same. It's exactly the same as solving equations. All right, so let's look at this one. If everything's exactly the same, I have n plus 5 is greater than or equal to 8. This is what I want you to think of this problem like in your head. I want you to think of it as n plus 5 equals 8. Okay, because everything is exactly the same as equations. Let's just treat it like it is. All right, this is what I'm thinking. Okay, this is what I'm thinking, but this is what I'm going to use. I'm going to use the one on the left here. So if everything's the same, my goal is to get n all by itself. So I'm going to subtract 5 from both sides. If I do that, Then I get n, cancels out, is greater than or equal to 3. And now we know how to graph that from the previous examples. Find your 3, close circle, variable comes first so I can follow my arrow trick. Everything greater than or equal to 3. Okay. Next example. Do the same thing. Okay. I have 3x plus 1 is greater than or equal to negative 5. Okay, again, this is what I'm thinking. I'm thinking it's 3x plus 1 equals negative 5. So let's take a look. All right. I get, if I'm going to use it, I'm going to do this, I'm going to subtract 1, subtract 1. Okay, so I get negative 3x is greater than or equal to negative 5. Okay. Now, I put something in here. Check the solution. Let's pay attention to this. Next step is to divide by, I'm sorry, did I write negative 5? This is negative 6. Okay, my next step is now divide by negative 3. Divide by negative 3. Divide by negative 3. Okay, so when I do that, 3's cancel out. I get x is greater than, question mark here, think about that. X is greater than, negative divided by negative is positive 2. Okay, now that means that things like 3, 4, and 5 and other numbers greater than 2 should be a solution for this. Okay, but let's check and see if that's true. Okay, let's check and see if that's true. Let's just test 3. Okay, if I have negative 3 times 3 plus 1, we're testing to see if that is actually going to be greater than or equal to negative 5. Well, I got negative 9 here, plus 1 is greater than or equal to negative 5, and I really have, continuing on, I really have negative 8 is greater than or equal to negative 5. Now, is negative 8 greater than negative 5? Careful, there's negatives here. This is false. And I'm going to show you why in the next rule, okay? By the way, we did not do anything wrong. We made all the right moves, and this information still remains true. We treat it like an equation. Here's why we're wrong. There's only one thing different when solving inequalities, and this is a rule that you have to just know. If I multiply or divide both sides of an inequality by a negative, you must flip the symbol around, okay? You must flip the symbol around. So, let's go back at the last example. I divided by a negative 3 here, and I didn't flip the symbol. If I flip the symbol, I would have the correct answer. I would have instead x is less than 2, and I would be choosing numbers for a solution like 1 or 0. Okay? If I plug in 0 to this equation, I get 1 is greater than or equal to negative 5, which is true. Okay? So, bottom line, if you need to pause this to write this down, have the sub do it. If you multiply or divide both sides of an inequality by a negative, you must flip the symbol. All right? Let's go through some practice problems. So, solve and graph the solutions to the inequalities. So here we go. I got 2 minus c is greater than negative 2. Again, treat it just like an equation. I'm trying to get c all by itself. And here we go. I'm going to subtract 2 minus 2. So I'm left with negative c is greater than negative 4. Okay? Now, remember, I have a negative here. I can't finish with that negative. So I have to divide by negative 1, divide by negative 1, and I have to flip the symbol. So that gives me c is now, instead of greater than, less than positive 4. Okay? Now if I graph that solution, I have my number that I'm talking about, 4. I have an open circle, and I'm graphing numbers that are less than it. Okay. Next example. I got 4 minus 3q is greater than 13. So I'm going to subtract 4 minus 4. Negative 3q is greater than, I get positive 9. That's positive 9. Let me just make that there. Minus 4, I get positive 9. okay? Divide by -3. Divide by -3. That means I must, again, flip the symbol. So I get, that cancels out, Q is less than -3. And I find the number I'm talking about, -3. I get an open circle again, and I graph everything that is less than it. Okay. Again, if you're graphing these, this is all you really need to write down. -4, -3, -2, number line, tick marks, open circle to the left. Okay? All right. Last example, and then we are done. I got 7k plus 4 is greater than or equal to -10. Okay. -4. -4. I get 7k is greater than or equal to -14. Divide by 2. Divide by 2. Now, be thinkers. Do I have to flip the symbol? Just because I did it in the last 3 doesn't mean I have to do it on this one? No. Think it through. It's not a negative. Okay? Oh, divide by 7. If I divide by 7, I get k is greater than or equal to -2. Okay? Graph that solution. Find -2. Filled in circle. And I'm graphing everything that is greater than it. That away. All right, guys, that is the lesson for today. This stuff will be on my website. The notes are also there. If you need any other extra help, please feel free to ask any of the other teachers. They should be able to help you out with this. Math Lab is also available to you. The schedules are posted in my room. I will be back on Monday, as promised. Tomorrow you guys have some WKC test prep with some instructions that the sub will give you tomorrow. Okay? You should have a good chunk of time right now to do some homework. I expect you to be productive. I expect you to get work done. Please take advantage of the time that you have. Have a good one. We'll see you Monday.